Hi everyone, my name is Shubham Godke. I am a data engineer and in this video I will be walking through my solution to the Calgary HTTP Dataset Analysis Assessment. I will cover how I loaded a person the data, how I cleaned it and then go through each of the 10 analysis questions. Let's get started. So the first I did was import the libraries I need. I'm using gzip to read the compressed files re for regex parsing, URL lib to download the dataset, date time for timestamp parsing, and pandas for data manipulation. I also tried to import PySpark here. In a local environment, it's not always installed, to, so I wrapped it in a try except block. In production, the same code runs on an EMR cluster with the Spark. The logic is exactly the same either way. Next is the download step. The dataset is a gzip file hosted on an FTP server. I'm using URL lib request to fetch it. I added a simple check at the start. If the file already exists, skips it skips the download. This way, if you rerun the notebook, it doesn't download it again. The file is about 5.4 MB compressed and around 52 MB when extracted. This is the core parsing logic. The category log format has 5 fields separated by space, host timestamps inside square brackets, file name, HTTP status code, and bytes. I write a regex pattern to extract 5 fields at once. Then I parse the timestamp using strip time. The format is day of week, month, name, day, time, and year. This strip call is important because single digit days have a leading space like space 3, which would break the parsing if you don't handle it. The bytes field can be dash for redirect responses and 3 not 4 not modified. Those don't send a body, so there's no byte count. I store this as known, which becomes NAN is pandas. I also extract the file extension from the file name extension and compute the data string and hover at first time, so I don't have to compute them repeatedly in each analysis function. The load function reads through the compressed files in line by line. I'm using Latin 1 encoding because these are old 1990s logs and there can be some non-ASCII characters. The errors replace makes sure it never crashes on a bad type byte. After loading, we have 7,26,738 records with 0 bad lines. The data covers October 1994 to November 1995. Looking at the EDA output, the bytes columns has around 94,000 null values, which are the redirect and 304 responses I mentioned. Everything else is clean with no nulls. The status codes are 200, 301, 302, 304, and 403, 404, and 500. A typical distribution for a web server. Question 1. is straightforward. Total records uh, length df gives us 7,26,728. In question 2, unique host, the result is 2. I want to explain this because it might look surprising. This particular dataset doesn't store individual IP addresses. Instead of classified every request as either local, meaning it comes from inside the University of Calgary network, or remote, meaning it comes from outside. So there are exactly two unique host values in this dataset, and that's the correct answer. In question 3, date-wise unique file name counts, I grouped by the date column and called n unique on file name. This gives us a directory with 392 dates and the count of distinct files requested on each day. In question 4, 4024 count 36,151 requests, return a 404 not found. That's about 5% of all requests. In question 5, top 15 file names causing 404s, I filter for 404 rows, then run value counts to find the most frequently missing files. In sixth question, top extensions causing 404s GIF files are the most common, followed by HTML. This makes sense because image files often get moved or deleted and the link break. In seventh question, bandwidth for July 1995, I filter for July 1995 rows with a not null value byte values, then group by date and summed. The not NA filter is equivalent to is not null is SQL. It excludes the direct responses that have no bytes counts. Each day in a July saw roughly 75 to 83 million bytes transformed. In, in this question, hourly request distribution, I counted requests per hour across the whole dataset. I initialized all 24 hours to 0 first to make sure hours with no traffic still appear in the result. The traffic is fairly even across all hours since this is a university server with the global visitors. In ninth question, top 10 most requested files overall value counts on the file name column across all rows regardless of status code, index.html and the common image file top the list. In last question, status code distribution 200 OK makes up about 80% of traffic. 304 not modified is around 10% and 404 is about 5%. This looks like a healthy normal distribution for a web server of this era. That covers all 10 questions. The approach was pretty standard. First, the raw log into a clean data frame, handle the edge cases like null bytes and space paddle timestamps, pre-compute the columns I needed, and then keep each analysis function simple and focused. The full notebook with the outputs, the HTML expert, readme and transcript are all in the submission zip. Thank you for watching.